Our next speaker is Mr. Zach Jensen, and Zach is like a lot of you in the room. He has microsurfacing in his DNA. His grandfather and uncles were with the company Baloo Construction. That was one of the first, or the first company in the United States to do microsurfacing, brought microsurfacing to the United States. His father, Alan Jensen, has been in the business his entire life and now works for Road Science or Armaz or what is it? I don't know. And then Zach has started as soon as you could with Baloo Construction. Started in the field, worked his way up to foreman, and then decided to get away from construction. Went to work for Bergkamp Incorporated. Was with Bergkamp for how long have you been with them? 14 years. Actually started building the machines, then went into tech rep, and then went into product management, and that's where you are today. Is that right? Okay, so now one thing, come on up and get going, but I just want to say, remember I told you this thing isn't accurate. Jimmy Kendrick is listed here as who was going to give this presentation. Jimmy's daughter is playing in the Mississippi high school golf tournament this week, so he called in a reliever. Go get him.
Thanks, Rex, and thank you all for having me. I know I'm not Jimmy, but hopefully I will suffice, and we can talk about innovations in pavement preservation equipment technology. This is something I am very close in with, being my background in building the equipment, tech rep, and now product management, which is where I'm heavily involved in the innovation side. So what we're going to cover with our innovations is first we're going to look back at what the equipment was. We're going to talk about mechanical. So how the mechanical best describes is we're going to go over the paver calibration, paver setup, and material readouts. I think that's going to best illustrate where we were to show what we're doing now on our electronic pavers. Again, we're going to just do an apples to apples comparison of paver calibration, our paver setup, and this is all tied to a job mix formula, and then our material readouts. So not only are we going to talk about what we're doing in our microsurfacing versus our paver calibration, paver setups, we can also show material and machine reporting. This is where the innovation really kind of comes into play. And then we'll talk about new equipment beyond microsurfacing. So when we're talking about pavement preservation equipment, microsurfacing equipment, really started back in the 70s, the 80s, I believe, was when the first continuous paver was produced by Bergkamp Incorporated. It was called a mechanical paver, where you had a jack shaft system, you had a mechanical adjustment gate, and that really is what controlled your ratio between your aggregate and your emulsion. And there's a couple things on that jack shaft that tied in your mineral filler. And then your water and your additive, field additive, were controlled very mechanically and manually. So when we're looking at this paver, there's a lot of knobs, there's a lot of dials to dial in, and you got to adjust. And as we know, we don't live in a perfect world, as the lab does, right, Jamie? So we have to make those adjustments. When a job mix formula calls for a range of 11 to 13% on our emulsion, and we're also dealing with moisture in our aggregate out in the field, we have to adjust that. That is done the gate, and a human is actually adjusting that gate. As we all try to be as perfect as we can also misread and misadjust, so our ratios could be off a little bit. Not saying we're still perfect today, but we're a little bit closer. So when we're calibrating on this adjustable gate and we don't know what our aggregate weighs, we have to run 3 samples at 3 different gate settings. And this is kind of what that looked like. So sample 1, 2, 3 at 3 inches, 3 more samples at a 4-inch setting, and 3 more samples at a 5-inch setting. This is very labor intensive, and depending on what type of scale setup you have, you could be doing a lot of shoveling. And then that's not to forget about the fact that we also have ISSA guidelines that, as the equipment manufacturer, we're abide by following. So ISSA recommends, or they're really mandating, a 2% deviation between our average scale factor of all of it and then our samples. So we'd have to do manual calculations to figure out our deviation, and if we're outside that 2%, we have to do more samples just to make sure we're honed in and we're getting a correct average. So once we figure out that average of all 3 gate settings, we would plot it on our graph at what gate setting and where that was of our pounds per our average. And then you'd have to draw a line. If that line was not touching all 3 points, we had a bad calibration. We have to start all over again. As a contractor, I'm sure there's ways, but the machine's not producing mix. So this is very, again, time consuming. It's part of the job, but it's not, it's just eating into production time. So it's very labor intensive. And then we also have to calculate in our emulsion. So based off of the job mix formula, if you're wanting say a 12% emulsion and our calibration came out at 4 pounds per count, that's where we would graph it. And this is all based off of a dry aggregate. As the lab does it, they're doing a dry aggregate. So you'd still have to factor in the moisture and regraph it, and it would look probably something a little bit up here and come down, so you're adjusting that gate. And that's just at the point of calibration. If you got a rain the night before, after you calibrated, you'd still have to go and factor in your new moisture. And then you're adjusting your gate throughout the day, depending on how many times you're checking your moisture. And then it was pretty much all stored on a paper copy long before computers were really involved in the industry. And then as computers got more pronounced in the industry, Excel spreadsheets kind of helped expedite this and keep a log. But if that paper copy was lost and your calibration was lost, you really had nothing to go off of, because your calibration is helping achieve or calculate your application rate, your pounds per square yard, because everything's based off of your scale factor. And then we had these very analog readouts. We very first started with the upper left-hand corner. That is called a Gemini 5200, and that's what really bound our mineral filler ratio. So we had 1% mineral filler to 100% aggregate, and we had a couple of sensors on the machine watching our aggregate and our pounds per count of our mineral filler. And then as technology advanced, we moved down to a little digital display, had some images to kind of help show what was going on. And that way we can kind of maintain that ratio a little bit more easily and more accessible. And then, as I mentioned, our water and additive, we have mechanical dials right here, and then a little readout to show you what you're putting in for gallons per minute. And then if you got paid a visit by a material supplier and they're asking how much additive, you're kind of hoping that these things worked and paid attention to, because they also had to be calibrated in a specific way. So back when I started, and probably a lot of you started when you're standing on the back of the paver, there was a lot of art to watching the material and making sure you had a good consistency, everything was right, good emulsion coming out, and your pavement looks good and you can see it breaking behind you. You probably didn't rely on a lot of these readouts and just went off of the feel. So now as we advanced, in about 2008, we started introducing a fixed gate which came along with our computer system. So as I mentioned, it is a fixed gate. It does not adjust. It is all computerized. The computer is controlling the calculations, and it's actually storing your calibrations and storing your materials, your usage. And then you can get provided a report by what you did at the end of the day. So instead of having a paper copy and writing out all of your calibrations and having a calculator and doing your math, you're logging it all into the computer. So in the computer, as you can see here, the far left column, the black boxes, those are what you can enter in. So you have your heavyweight as your gross and your lightweight as your tare. So depending on what kind of scale you have and what your setup is, those numbers could be either weighing the entire machine or weighing a batch sample when you calibrate. The computer will calculate what your net is depending on if you tear out your catch container. And then it's also going off of your count, so your pounds per count. We are looking at the components at a higher resolution with our sensors, so the counts are a lot more higher to what you're used to when you're looking at a air counter. So when you, for example, an air counter on a mechanical paver is counting 2 counts per revolution, to whereas on an electronic paver, it's counting 250 times a revolution of the conveyor belt. So resolution is a lot higher. So that's why your scale factor, your pounds per count is going to be in more decibels than whole numbers. The computer is also calculating your deviation. So you can know instantly if you have a bad calibration, you're outside of that ISSA 2% deviation guideline. And you can do upwards to 6 calibrations per material. So if you have, in this example, 4 samples and one's a bad one, you know exactly where that bad one is. And you could probably start to do a little troubleshooting of what happened, because with calibration, it does happen to need a more specific process, and mind your P's and Q's of what you're doing and what's on the scale. Down below this information, we do have our dry scale factor. As the lab does it, everything's based off of 100% dry aggregate, so we have to factor out the moisture of the rock, and we enter in that moisture here. So instead of on a mechanical paver where we're doing our +1, it's all, you just enter in the percentage based off of what that moisture is. And then the computer's going to factor in the moisture to get you your average scale factor of what's being done in the field. So calibration, it's a with a fixed gate, you have to really get 3 samples versus the mechanical paver where you're doing a minimum of 9 samples. So not only does it cut down on labor, but it also helps be a little bit more accurate. As we mentioned, the 250 times of resolution, we can see our deviations a little bit better instead of manually calculating it out. And this is just an example for the aggregate. The calibration is similar for all the materials on the paver. So when you have your job mix formula, as we all notice here, we take our mineral filler and just type it in. Same thing with our emulsion, you just type it in. And then with technology and programming, we could also do residual asphalt if that's what you want to pave with instead of emulsion %. So by changing it, it's just a simple type. So you can type it in, and the same thing with your aggregate daily moisture. So instead of adjusting the gate, regraphing out, if you want to play around with your ratios of emulsion or mineral filler and changing a bunch of dials, it's all right here on the computer. And as Dr. Vargas was saying, everything's kind of on a cell phone, and we're recognizing this is really a data-driven world. So with the electronic pavers, you have more accessibility at your hand. So with your cell phone and these newer pavers, you have telematics. So you could do a remote view. So as a contractor or equipment owner, project manager, you could log in on your phone and look at this page right here. So part of the material readouts is everything going on is right here on this display at the back of the machine. And also, if you're not there on the job, you can log on and see what's going on, and you can thumb through the entire machine page by page, just like you're standing on the back of the paver, to look at your set points. But not only do you have to thumb through the pages, it could also be on the home page. So down here, a set point, we can see that the operator has their emulsion percent set at 13%. They're online, we can see what the machine is actually producing, and then we can see what the average is throughout the day. Same thing with mineral filler, water, and additive. We can see what exactly they're putting in percent-wise to the mix. And water, if they have, say, 4% typed in as their aggregate moisture and their water's all the way off, we're calculating in that 4% is going into the mix of water. So we really have to be starting checking our aggregate moisture. That way we know what's going into the mix. There's other dials going on in here, so we can see our pounds per minute going in of just raw aggregate, see our gallons per minute of water and additive, and pounds per minute of emulsion going into the mix. And that's all being calculated in the back based off of our calibration. Up top, we also have your mineral filler pounds per minute, and that's all tying into what we discussed of our set points, and see what we're going at a percentage base. You could also see how fast the paver is moving, how wide you're applying it, and then that is tied into an application rate. There's other sensors on the machine, radars, box width sensors. That way you can be as accurate as you could or can, and that way we know what we're putting down. The machine is also capable of producing a hard printout copy at the end of the day, and depending on what you're set up for, if you want one every 500 feet, one every road, every job, the computer can print it off based off of what you want. It's just a click of a button and the machine will start printing off the reports. And here's what the tickets will look like. You can change the job, so if you're doing a ticket per road, you can title the ticket inside the computer, say Highway 3, and then if tomorrow you're going to pave Highway 4, you can rename it Highway 4 for that day. That way your tickets are dated and titled what you actually paved and put down on that. So you have the name of the aggregate, the name of the emulsion, and the name of the mineral filler, and additive if you choose to use so. And then what you put in tons, pounds, and then what the machine was actually set at during that day. It can also do a little bit more in depth, so you can print off your scale factors, or which is your pounds per count. And then it can also print off your counters. So instead of the AirLogic counters where you're writing them down at the end of the day to do your end run sheet, you can print it off and have a hard copy right there. Again, as we mentioned of our cell phones, if you're away from the job and you have access, you can do a remote view. So you can thumb through all these pages to watch in real time what's going on at the back of the machine, and you can see what the machine is set up, what it is doing, and it's also used for troubleshooting. So if the machine is down, instead of trying to call in a tech rep and thumb through or navigate the computer system and make sure everyone's on the same page, a tech rep can log in with your permission and take control and look at what's going on to do any testing or validation or actually monitor the machine of what it's doing. Because with MCADs inside the program, the D of MCADs is diagnostics. So a lot of these red LEDs are signals to let you know what is active within the paver. And then you could also watch the parameters of the feedback loop, so PID, and you can also see what's going on in the frequencies of the systems to make sure that it is actually engaging when it is being demanded to be engaged. So that's just the remote view portion. Some other material readouts is what's called the web portal. So with telematics, you can also do GPS location. I apologize, it's kind of hard to see with the white, but everything that was on that ticket that was printed off at the back of the paver can be viewed from a laptop or a phone or a tablet. Most probably with this page prefer a laptop, but you can see the aggregate, the emulsion, you can see the place of the paver, and you can name the paver, whatever, if you have unit 524, you can see what 524 is doing. There's also other metrics, as you can probably see, set points and ratios, so you can see it in the percentage format, what the machine is doing versus what it's set up to do. Hydraulic temperatures, if you have a mechanic that's off-site and who wants to peek in on what those hydraulic temperatures are performing at. And then all of this can be exported to an Excel spreadsheet. So if you want a history of what was going on throughout the day, you can print it off, make a report into Excel spreadsheet, and that way you have it in your files. Other reporting is on the material tracking side, you can set this up to watch your aggregate, you can watch your emulsion, mineral filler, application rate, whatever metric is being pushed up to the cloud can be reported in a map or a plot graph. And you can do it over a span of a time, not just in one day. So as for this example, I believe it is set up for, call it 3 days. See, on day one, they produced X amount of tons. They shut down and started on day 2. And you can see the stops and starts and how long they were actually stopping and waiting before they started paving again or producing that material. We do have it set up within the parameters that when we think the machine is paving, it's actually looking at more than just one signal. A lot of things have to be engaged for we recognize it's paving mode, so we're not counting this as just dumping off aggregate at the end of the day. A lot of things have to be engaged for it to be in paving mode and reporting as paving material. And you can do this with every function or every thing that's being reported. It's really helpful to help paint the picture as someone in the office. I'm sure Rex was waiting at Baloo 3 days. What'd you do 3 days ago? And you'd have to wait for someone to get to the hotel, make the phone call, or fill out their daily logs, where you can log in and actually make this report yourself in live time. There is a little bit of a lag time to get these reports, so every time the machine sends up a ping, which is 5 minutes or whenever it gets a signal, so that's when it's going to be refreshing. And when they zero the counters on the back of the machine, that's when you see this drop down. And then you can see them start up. Again, it really paints the picture, so this looks like it may have been over a weekend, and based off of how long you have that report set up for, that's when they start paving and when it cuts off. So if you wanted to advance that report to a week or a couple of weeks, you can see what happened within that time frame. So other equipment that we have that's beyond the microsurfacing realm is the journeyman plant. The journeyman plant is a central mix plant for cold recycling. It is set up to do either virgin aggregate or 100% wrap. And it is a mobile plant, does all the mixing right there at your stockpile or your location. It does have, in this image, it has a single hopper. We're also have options for a 3-hopper, or you could do a divided hopper and a secondary aggregate hopper. And it is controlled by MCAD, so all the technology that we just talked about is integrated into this machine. We have incline belt to our pug mill. It does have options for an emulsion storage tank, or you can load directly off of a tanker, and option for a mineral filler hopper. This is a brand new piece of equipment for us. We're very excited, and we're also very excited that This one is being built in the plant today, and it's coming along quite nicely as it is almost completed. That's really all I had to present for innovation. Any questions for me? Perfect. Well, please stop by the booth, and if you have anything, that will be there. Thank you.